Okay, so I'm back, and now I have taken two resistors and I have put them head to tail. So it's like a big conga line going from the battery to resistor number 1 and then going around to resistor number 2. So I kept resistor number 1 at 10 ohms, so that's this one up here. So this one up here is still going to be 10 ohms, so I'm calling that resistor number 1. And then this one down here is going to be resistor number 2. So I'm going to let you, and I set this one for 20 ohms. All right, so go ahead and make that circuit. So that circuit is going to be called a series circuit, when one resistor follows after the next resistor. All right, now before we do any calculations on this, I want you just to look at the electrons, and I want you to compare the speed of those electrons right now to the speed that the electrons had before. So if I go back here and let's cut out the resistor, just pull it down and then reconnect it. All right, so do you see the speed of the electrons? All right, now let's go and open it back up, put the resistor back in there, look at the speed of the electrons now. How is that related to the current? So the current has decreased. So evidently, as the number of resistors in a series circuit increases, it somehow decreases the electrical current. All right? And so let's also now let's actually measure some stuff, and then we will calculate it later. So it's still the same battery. It's a 9-volt battery on each one of those. So now I'm going to take my voltmeter and I'm going to put it across resistor number 1, and it says 3 volts. So what I'm going to say over here, voltage number 1, so the voltage across resistor number 1 is going to be 3 volts. All right, now you do it for resistor number 2. And make a prediction. What do you think the number should be? If you can't figure it out, don't worry about it. But you should, hopefully, know what the answer is. So if I take my 2 probes and I put them across resistor number 2, I'm getting 6 volts. So I'm going to say voltage across resistor 2 is going to be 6 volts. Now, why did I say that you ought to know what the answer is? Because what's coming out of the battery was 9, and 3 of it was being used for resistor 1, so that leaves 6 of it for resistor 2. 3 plus 6 makes 9. Okay, and so let's also calculate, or let's measure the current. So do you remember how to do that? So go ahead and do it. All right, so that I'm going to open the circuit, and I'm going to take the current meter and I'm going to put it in there. Okay, and getting 0.3 amps. So 0.3 amps of current. So let's put that over here. Current is equal to 0.3 amps. Now, get out another current meter. So let's grab another one. Could you put that one in somewhere else? So let's find out what is the current right here. So how would you do that? You would open up the circuit, and you need to put the ammeter in there. And what do you notice? It's the same number. And then I'm not going to do it, but I'll let you do it. Take out another one, and why don't you put it right here and see what happens. And you'd find it's the same number. So in a series circuit, the current is the same everywhere. It doesn't make any difference where you put the ammeter. It's going to have the same current everywhere in the series circuit. Okay, so now I'm going to finally, let's put this away. And now let's go back to our notes. And we have, this is a summary of series and parallel circuits. So what we have figured out is that in a series circuit, so here's our picture of a series circuit, the current I is the same everywhere in the series circuit, and we've just found out that the total voltage is equal to the sum of the voltages. 3 plus 6 makes 9. So that's what we have just figured out. Now there's one more piece of information on this that is important, and that's the total resistance. So the total resistance R, so R sub T, is going to equal R1 plus R2. R1 was 10. R2 is 20. So the total resistance is going to be 30 ohms. That's important. All right, let's go to our next slide here. We're going to come back to the parallel here in just a few moments. But let's go to here. And this is how to solve a series circuit or how to solve a parallel circuit. So right now we're doing the purple. How to solve a series circuit. Okay, here's our picture. So that is, again, going to be this thing here. So there's our picture of what's going on. And it says step 1 is to calculate the total resistance, which we just did. The total resistance is 30 ohms. All right, now the second step is we're going to make use of Ohm's law. So Ohm's law is that V equals IR. So up here. But I'm going to put T, T, and T. Total voltage equals total current times total resistance. So what could we do? We're going to take the total voltage, which was 9 volts. That's going to equal the total current, which we don't know. But we do know the total resistance is this number here. So all we've got to do is take 9 divided by 30, and then when you round it, you get this number here. So we've just verified that those equations work. Okay, then the next step is, now that we've got this thing, so now that we've got the total current, how could we use that to figure out the voltages? So we're going to say that voltage 1 equals current 1 resistor 1. It just went off the board there. I'm making a mess. So voltage 1 is equal to current 1, resistor 1. Barely. All right, got that? Okay, so we know that current 1 is going to be the 0.3, and we know that resistor number 1 is the 10. So therefore 10 times 0.3 is going to be 3 volts. Now you do it for the other one. So we want to find voltage number 2. So it's got to be equal to current number 2, resistor number 2. Okay, we know the current is 0.3, and we know that the resistor number 2 is 20. So multiply the two together and you get 6 volts. So we have just verified that that works. And then if we go back to our original picture here, the current is the same everywhere in the series circuit. So the current was the same number no matter where you put the ammeter. And then the sum of the voltages was equal to the total voltage. Pretty cool. All right, we're going to take a break. When we come back, we're going to do it for the parallel circuit.